In this video, we're gonna look at the basics of using Simplicity Studio 5, especially we're gonna see how we can use GPIOs, which are the buttons and LEDs on the dev board. So I already have the board connected, which is the XG24, and I started Simplicity Studio. I'm using here version 5. So let's click on Start. And we're gonna go to example projects to see the demos that come with the SDK. So I want the Blinky FreeRTOS demo. So we don't want the Bluetooth variants. This is gonna include Bluetooth in the code. We just want the FreeRTOS. So usually they are called platform, things that are basic microcontroller stuff like GPIO and communications are part of the platform. So this is the one we want, Blink kernel FreeRTOS. So let's import this into our workspace by clicking on Create. We can change the name of the project. So I'm just going to call it 01 and keep everything the same. Keep this as the default. Link SDK and copy project. So it doesn't replicate the SDK, just replicate the project. And at this point, our project should be imported and should appear on the left side. All right, so here is the project. The README usually opens automatically. The SLCP, we can open it by clicking on this. And the codes are here. Notice there are two folder autogen. This is code that's automatically generated. So if we change something in SLCP, it automatically generates codes here. And config has configuration file. Those we can edit. Those we're not supposed to edit them because they will be generated automatically each time we compile. So this code blinks an LED, and roughly speaking, what happens, we start in the main. Main is gonna call functions that initialize the application. Main is gonna call the function that initialize the application, which is this app init. And after that, main is gonna start the scheduler. So this function eventually is gonna start the FreeRTOS scheduler. So here we have app.c. This kind of sets up the application. So it simply calls blink init. There isn't much it is doing. And if we go to blink, this is where most of the code is. So blink init is this function. This is gonna be called only once, and its job is to create the task, the RTOS task. So this is the RTOS task being created in blink task, and it's gonna execute in here. So what it's doing, it's waiting on a delay and toggling the LED. So basically the LED is gonna flash. So the delay is, first we have toggle delay millisecond defined at the top, which is 1000. And this is gonna convert milliseconds, 1000 milliseconds to tick period. So usually vtask delay creates a delay in terms of tick period. Once we have the tick period, we pass it to here, and that's gonna create a delay. And otherwise the LED will be toggled. So this code is ready to run. So let's build it. To build it, we're gonna right-click, click on Run As, and Silicon Labs ARM program. So first time we compile the project, it takes a little bit of time because it's really compiling everything from scratch. But then if later on, further compilation will be faster since we're only recompiling the code that has been modified. So nonetheless, that wasn't too bad. Now it's flashing. This green bar shows that the code is flashing. And indeed, in front of me, I can see one of the LEDs flashing every 1 second. What we're gonna do next is we're gonna add the other LED. So our board has 2 LEDs. And if I go here to the PDF of our file, of our board, we see that we have two LEDs. Let's see where they are here. Now here they are, LED 1, LED 0. And we have two push buttons as well. And this is another block diagram, shows the LEDs go to GPIO, and this is the actual mapping. So the LEDs are port A, bit 4, and port A, bit 7. And the buttons are port B, bit 2, and bit 3. So one thing I can do here, if I go to the SLCP, you can either double click, but it's been already open. I can go there. If I go to the pin tool under configuration, if I go to pin tool, so we can see that one of the LEDs has already been added to the project. So this is LED 0, which is port A, bit 4. So now let's see how we can add the other LED to the project. We're gonna go here under software components. Everything GPIO is under platform. So notice you have Bluetooth, Wi-Fi, other like module, but everything that's normal microcontroller stuff usually falls under platform. So let's go there. We're gonna go under driver and under LED, simple LED. So it's already installed. You can see there's uninstall. That mean install mean it merges the code, include all the file and copy some source file. And all I have to do is add instance. So it automatically recognizes LED 1 could be added. The project know which board I'm using, so it knows the mapping. So all I have to do is click done. So if I go up here, you can see this guy knows I'm using MG24, which is my dev board. So it's gonna do all the mapping correctly. So you can see here now we have another GPIO LED1, which is 7. So port A, 4 and 7, indeed, where the LEDs are mapped. So when I added the other LED here, something happened, which is in the AutoGen folder, code was generated. So there's LED instances, .h and .c. Let's open these files. So in the .h, now we have two LEDs. If you open that before you add it, it will show one. And this is what the LEDs are called: SL, LED, LED 0, and LED 1 as well. So I can use these are struct, basically. I can use these struct in my code to access those two LEDs. .c file shows what has been done, and the init function will be called. So those are actually initialized. So they are ready to be used in my code. So remember the name, SL, LED, LED 0, and 1. Let's go back to the Blink C, and you can see this guy has already been used here. So I'm gonna copy this. I'm gonna erase this define, and I'm gonna go there and just put it here directly. So that struct that's defined in the .h file can be used immediately here. This file is already included, right? That LED instances is already included. So I can access this. And on top of that, now we have LED 1. So if I build this code, I should see both LEDs flashing. So let's do that. Again, right click, run as, and that should do it. Takes a bit to compile since the AutoGen were changed, so that's gonna compile everything. And indeed, in front of me, I see both LEDs flashing. So this is how we add an LED. So let's do the push buttons, and I'm gonna close some stuff around here. So notice that the file, the code I have is in blink.c. So I'm gonna save it. So I'm gonna rename this first, 01. So now it is here. This code's still built because it doesn't matter what you call the file. What matters are whether these functions are found. I'm gonna build it just to confirm. So as you can see, it built. File name doesn't really matter. And what I'm gonna do now, I'm gonna save as. So gonna click File, Save As, and I'm gonna create another one, Blink, with buttons. So these two files will not compile together because they have the same function names. So I'm gonna exclude this. I'm gonna right click on it, click on resource, and exclude from build. And double check check this mark, GNU ARM, this is a compiler. And now you can see that the file 01 blink is kind of shaded and marked with this bar. That means it's not going to be compiled. So only this will be compiled, which is what I want. So I'm just preserving my old code and I'm writing another code. So let's just confirm this builds. All right, so that looks good. Again, two LEDs are flashing. So let's add the push buttons. So push buttons are port B, bit 2, and bit 3. So we're gonna do a similar procedure. Go to here, under platform, driver. We want the button. Since no button has been added yet, we need to click on install. Install is gonna do includes and copy some source files and some autogen files. So if you see here, there is no button instances. When we click install, it's probably gonna create some. Not yet. We need to add the button instances from here. So let's go to simple button, install, and this is gonna add button 0. And now you can see the autogen file button instances. Of course, that's gonna have one button instance. You can see it only one. Let's add the other button. Add new instances, button 1. And now there are 2 button instances, and those are gonna be called SL button btn0, btn1. So I'm gonna use these names in my code. Let me copy this to my code inside my task. So somewhere here, I'm gonna use that button instance. And let's do a quick confirmation. If we go to the pin tool, you can see here, we have the buttons have been added, and indeed they are port B, bit 2, and bit 3. So the mapping is good, so this is fine. And next question is how to find the API functions. So one convenient thing is while you are at button, you can click documentation, you can click this open in browser. That's gonna take you directly to the documentation. And similarly, for the LED, if you click on open in browser, that's gonna take you straight to the documentation. Otherwise, we can go to docs.scilabs.com, go to platform. There's a tile for every type of SDK module. We need platform for GPIOs. Here it is, platform, and driver API documentation. And let's check the LED first. So LED driver, and these are some of the functions we can use. SL LED turn on, turn off, toggle. This is what we usually use. This was called by the .c here. You don't need to call this, and you can get the state. So back to the code, you can see it's using toggle, SL LED toggle. So it's using this. We can use this or this, and pass the LED struct with ampersand. It's passed by reference. All right, let's find the button. So that's the LED driver, button API, load it here. So these are the functions for the button. This is the name of the interrupt handler if we want to do interrupts. And those are functions we can call. This is the function I want, SL button get state. And we will pass the button structure with ampersand because it's passed by reference. And it's gonna return this. We can click on here to read the return type. It's gonna return true or false, basically. So this will be the return button state. So I'm gonna copy this button state, and if let's call button state pass button 0. Remember, it's passed by reference, so ampersand. So if the button is pushed, this is button 0. So LED 0 should turn on. SL LED. If you remember, this was the function name to turn it on. SL LED turn on, else turn off. So that's gonna have the button lit as long as I push the button. And as soon as I release it, it's gonna turn the button off. And let's do the same for the other button. It's called button 1 and with LED 1. So let's comment this out. I'm gonna remove the delay. So this code is gonna basically keep running nonstop as fast as it could. That task is gonna hog the CPU basically. It never blocks. But just for a simple test, this will confirm to me I added those correctly. So I think we're ready to build. Right click. Again, compilation time is a bit long because we added the buttons. Otherwise, it should be a bit faster. All right, we have a compilation error, so we're gonna click here on problems. SL button 0 undeclared. So let's see here. Autogen is where button instances and LED instances are created. And if you notice, those had been already added, the LED. This project came with the LED built in. So when these are auto-generated, what we want to use from it, we're supposed to include in the code. So I'm gonna include button instances. So the file name, let's just copy it from here. I like to put a comment that when I add things to the code, I just put a comment added by me. So later I know I added this, just a nice practice. And let's see now if this is gonna build, run as, right, to build it. All right. Now everything looks good, so I'm gonna test it. Now both LEDs are turned off. If I click one button, one LED turn on, and it turns off as soon as I release it. And the same work for the other button. If I push both of them, I can see two LEDs turn off. So that code works fine. So I just want to do one more thing. What's not nice about this code is it pulls the button nonstop, right? It's doing if, and then back, if. So this is nonstop. So it's better to use interrupt. But if we're not using interrupts, what I would do, I would put a delay of 100 milliseconds, because the fastest the user could push a button is about 75 milliseconds. So if I delay it by 100 milliseconds, the user will not see any delay, and that task will not hog the CPU, right? It will just do one polling per 100 milliseconds. So let's do this like so. I'm gonna take the macro, put it here, and I'm gonna put 100 in there, right? So this will convert 100 milliseconds to tick periods, and this will wait for that many tick periods. So the code is gonna do this and then block. So the scheduler is not gonna bother with this task for 100 milliseconds. After 100 milliseconds, it will unblock. It goes to the next line, but the infinite loop will repeat, check again, and block. So that should give me the same experience as a user, because this is a very small day. So now when when I build it, the compilation time should be fast because I only change one line. All the other files don't need to be compiled and linked together. So we should get like a fast compilation time, like 2 or 3 seconds. So run as, all right. And I'm gonna test the code. And to me, it works the same with or without 100 millisecond delay. That's not a delay I can observe. So we're gonna wrap up here by one thing. Uh, uh, we were looking here at Silicon Labs documentation, and we can see here this is the latest version of the platform documentation, right? We're under platform. So Silicon Labs usually is gonna release a new version maybe once every month or once every 3-4 months. So it really depends. So how do we know we're using the correct one? It's not gonna change a lot from one version to the next, usually. Sometimes it could, but it will be nice if I know I'm using the exact documentation that matches my project. So to do this, uh, in my project, we're gonna open the SLCP file. It's already open. Let's just test this. So if you double click, it opens. And this is the, this shows all the versions of the SDK modules that I'm using. So generally, I'm using this SDK, 2024-12.2. By the way, this is from mid-25. This is from May or June 2025. It's not from 2024. And the platform I'm using, or the platform version, is 5120. So I guess officially I'm supposed to be here. 5120, so I think here. And the button API is pretty much the same. This didn't really change, so you can see it's the same function. But certainly, it will be nice to match what you are doing with what you have here, and that goes the same. If I was doing Bluetooth, you can see the Bluetooth version is here, 910. So I'm supposed to match that. So you notice that I'm not using the latest one. This is like from 6 months ago. But what if I want to change it to the latest one? I can basically click here and I can update this whole project to the latest version. I think some code will be generated automatically. I'm not sure if I have to manually go and change codes, but basically there is a way to change it also to another dev board. Let's say I have another dev board, I can change it to that. So I'm gonna just leave this as it is here. And we're gonna look at one more thing here. Let's click on, basically if we wanna install another version of the SDK, so this is the SDK version I have, we go to here to install. And this shows me the SDK that I have. Apparently my Simplicity Studio could be updated, and the SDK, of course, it could be updated since this is not the latest. So if I want to install another version of the SDK, I can click here on the 3 dots. Right now, it doesn't let me click because I'm supposed to update Simplicity Studio components, and then I can update the SDK, as that message here is saying. That's why I can't do this. But to develop for Bluetooth, this is the only thing that we need. Simplicity SDK that include platform and Bluetooth and pretty much everything on that board. So here, the 3 dots, it let me change my SDK to another version or install multiple SDK versions side by side if I have projects on multiple versions. So that's pretty much is it for this video.